So dear students, now we will do the next question, and the question is question number 13 and from exercise 6.5. Okay, so are you ready to do? Come here. What is given in the question? We'll see this. In right triangle ABC, angle C is of 90 degree, and we have to prove that if D and E are the points on AC and BC respectively. These 2 points are already given in the question. So what we have to prove? We have to prove AE square, this one, plus BD square, this one, is equal to AB square plus DE square. So we have to join DE also. So join DE. AE, DB and DE we have to join according to the question. Now, I told you earlier also, if you will observe so many squares in the question, if it is, you have to prove for the things like that has so many squares, you have to do that question with the Pythagoras, and for applying Pythagoras, you should have 90 degree, angle of 90 degree. Just search it out in which triangles you'll have 90 degree and these sides. Just a combination of these two, you can able to solve the question. It's an easy question. If you will just see in which triangle we'll have to apply Pythagoras theorem. Okay, and the name of the triangle, these two prove give us themselves. They will tell us which triangle we'll have to take. Okay, so proof. AE square, this is AE square, and AE square will get in right triangle ACE. So I am taking the right triangle, in right triangle ACE, apply the Pythagoras theorem. The theorem is AC square plus CE square is equal to AE square. And this is result number 1. Okay. Now, second is BD. This is BD. And in which triangle you will get BD? In right triangle DCB. So, I am applying the Pythagoras in the next right triangle, that is DCB. So, similarly, in right triangle DCB, DC square plus BC square is equal to BD square, and this is, let's say, the equation number 2. Now, you will just have to see AE square and BD square, they are added over here, right? So, we have the value of AE square, we have the value of BD square. Now, what we have to do? We have to add these equations for getting this result, right? So add equation 1 and 2. Now add these two equations, AC square plus CE square plus DC square plus BC square is equal to AE square plus BD square. So I get this result after adding equation number 1 and 2. Now, see here, in right hand side, we want AB square, and AB square is present in this right triangle, AB. I can get this AB from AC square plus BC square. By applying the Pythagoras theorem, I can get AB square. So, AC square plus BC square, this one, AC square plus BC square. These two, the sum of these two square is equal to AB square. Again, by Pythagoras theorem, and in which triangle? ACB. Similarly, just look at this CE square and DC square. CE square and DC square. In this right triangle, tiny-miny, DCE. In this DCE right triangle, DC square plus CE square is equal to DE square. So, in spite of writing this, I can write DE square. Okay. Okay, and this is equal to AE square plus BD square. So now this result will change to this one, and this is what we have to prove. But you have to write why you have written AC square plus DC square as AB square and CE square plus DC square as DE square. So I will have to write this in the bracket here, the reason that okay, right, I write it here so that you can see this properly. The reason for this one is in right triangle ACB, AC square plus BC square equal to AB square, and in right triangle DCE, DC square plus CE square is equals to DE square. Okay, so AC square plus BC square I have put it as AB square, and DC square plus CE square I put it as DE square. So this is all about our result. This we have to prove. So we have completed this question number 13, 6.5. I hope you understand it. What we have done, we have just put the Pythagoras theorem in first triangle, second triangle, third triangle and fourth. This means 4 times we have to use the Pythagoras theorem. So that's a way of doing this question. Thank you.